guys, these are the notes for section 6.3. I guess here we go. This section, our objective is to learn to write. Oops, gotta do this, I always forget. Okay, write and solve equations for story problems. And what we're really going to talk about here is whether to use one variable or two variables in a story problem, and how to write a let statement for a story problem. So let's get to it. When translating word problems into algebraic equations, sometimes it will be easier to use one variable and one equation, and sometimes it's easier to use two variables and two equations. We're going to look at a couple problems where we'll do both ways and see what it looks like. So here's our first example, and I've kind of already done it. I just want to walk through it. The situation is a zoo has 2 fewer elephants than zebras and 5 times more monkeys than elephants. The total number of elephants, monkeys, and zebras is 30. And I suppose if this was a real problem, we'd want to figure out how many of each type of animal there was. Well, I've already written the equation over here as well. But what I really want to do again is walk through this to see how we got everything. So the first thing we talk about here is these things that we call let statements. Mathematical sentences, like the equation up here, are easier to understand when everyone knows what the variable represents. Right? We'd like to know what this variable represents in the equation, or at least when you write the equation, you should let everybody know what it represents. And we do this with a statement that describes what the variable represents. It is called, as I already said, a let statement. All right? In the above problem, we would want to write a let statement for the letter Z. And what do you think Z would represent? Well, of course, it would represent the number, I like the hashtag for the word number, of zebras. A little note here about let statements. They always, I think this is essential, they always indicate the units of measurement when applicable. Now, like we're saying Z is the number of zebras, so actually zebras is our unit of measurement. But like if this was feet, we wouldn't say it's the length, we'd say it's the length in feet, or it's the amount in gallons. We would include the units in your let statement when you write a let statement. All right? Next, are we going to use one variable or two? In this example, I've used one variable, but I want to talk about maybe using two. Once you have defined a variable, you need to decide whether to use one variable for the whole problem or multiple variables. For us, multiple variables is usually 2, but in this case, it would need to be 3 for different unknown amounts. If you choose one variable, then you represent the different unknown amounts based on how they compare, right? Different unknown amounts based on how they compare to the variable that you did use. We used Z. So how do the other unknown amounts compare to Z, the number of zebras? Let's look. I want to change colors here. In the above example, how would we represent the number of elephants? Well, we would look at how they compare to Z. And they told us in the problem that a zoo has 2 fewer elephants than zebras. All right, so that's how they compare to Z. There are 2 fewer elephants. So the number of elephants would be the number of zebras minus 2, right? Because there's 2 fewer elephants than zebras. Whatever the number of zebras is, the number of elephants is that number minus 2. And what about the number of monkeys? Well, how do they compare to something we already know? They told us that there are 5 times more monkeys than elephants. 5 times more monkeys than elephants. Hey, I know how many elephants there are. Z minus 2 is the number of elephants. And so the number of monkeys would be 5 times that amount. This would be the number of monkeys. And if you go up to our equation, you can see these are already in the equation, right? This is the number of monkeys. This is the number of elephants. And this is the number of zebras, right? So those amounts that we are using are going to be put into our equation at some point. The last thing then is we need to write the equation. So I know the equation is already written at the top, but how did we get that equation? Well, we got it based on the information in the problem. They told us in the problem that the total number of elephants, monkeys, and zebras was 30. So if I take the number of zebras and elephants and monkeys and I add them together, I know it equals 30. And to write this equation, I would use Z for zebras, I would use Z minus 2 for elephants, and I would use 5 times Z minus 2 for monkeys. And I have just written an equation using my let statements, or the amounts I represented in my let statements. All right, we're going to try an example next that uses 2 variables or 1 variable. Let's look at it. In this example, it says Elsie took all of her cans and bottles from home to the recycling center. The number of cans, I guess I have it on here, don't I? The number of cans was 1 more than 4 times the number of bottles. It says she earned 12 cents for each bottle and 10 cents for each can and ended up earning $2.18 in all. How many cans and bottles did she recycle? Well, it looks like there's my unknown amounts. How many cans and bottles did she recycle? How many cans? How many bottles? So I'm going to start out here with 1 variable. Generally, I would have my variable represent 1 of the unknown amounts. Right? And again, I showed you where we got that from the problem. The unknown amounts are how many cans and bottles did she recycle. So I could have the variable be the number of cans or the number of bottles. I think based on the problem, it would be better if I made it the number of bottles. So I'm going to write a let statement. I'm going to let B equal the number of bottles recycled. All right, I've got my 1 variable. So if I'm going to use 1 variable, then my other unknown amount, which is the number of cans, I need to represent it based on how it compares to the number of bottles, how it compares to B. And they told me how it compares to B. They told me right here that the number of cans was 1 more than 4 times the number of bottles. So I might write something like number of cans equals let's see, one more than 4 times the number of bottles. So I'd probably write 4b plus 1. That's one more than 4 times the number of bottles. And I've now represented my other unknown amount, the number of cans, using the same variable, b. So I have one variable, and now I need one equation. Let's see, is that it here? Yep. So we're going to write an equation then using these two amounts. All right, my two amounts are the b, that's the number of bottles, and the 4b plus 1. And I'm going to write an equation based on what I know about these. And here's what I know about them. Let me go back and show you if I can. I know that she got 12 cents for each bottle and 10 cents for each can. So, 12 cents for each bottle, that would be 12 cents times b. 12b would be the total number of cents she got for all the bottles she recycled. All right, the amount she got times how many she recycled. Plus, she got 10 cents for each can. So I'm going to multiply 10 cents times 4b plus 1. So that is the total amount she got for the bottles plus the total amount she got for the cans, and that equals her total amount, which is $2.18. But now we have a problem. Oops. So this total amount is in terms of dollars. But I was writing the other amounts in terms of cents. So now I'm going to have to put these other amounts in terms of dollars. 12 cents would be $0.12, and 10 cents would be written with a decimal like that, 0.10. And now I have an equation. And I could solve this equation, and we're going to solve it. So, the first thing I would do to solve this, perhaps, is I would distribute the 0.10. That would give me 0.12b plus, let's see, 0.10 times 4 is 0.4b, and 0.10 times 1 is 0.10, equals 218. Then I'd probably combine my like terms and get 0.52b plus 0.10 equals 218. Then I'd probably subtract the 0.10 from both sides and get 0.52b equals 2.08. And then I would divide by the 0.52 and get b equals 4. So, b is the number of bottles. Number of bottles equals 4. And once I know that, I can get the number of cans, right? The number of cans would be 4b plus 1, or 4 times 4 plus 1. 17 is the number of cans. And I have answered the question, and I did it using one variable. But on this one, I want to show you how we could also solve it using two variables. So let's look at that. Now, if you're going to use two variables, then you have a separate variable and a separate let statement for each unknown. I guess that means I would let b equal the number of bottles. Oops. And I would let maybe c equal the number of cans. So I have a separate variable for each unknown amount. Two variables, though, means I'm going to need two equations. So down here, I've kind of gone through that. here's what your two equations might look like. The first equation would tell you how these two variables compare to each other. And if you remember, I think the number of cans, let's actually write it out. Number of cans is 1 more than 4 times the number of bottles. So now that I'm using two variables, that just means the number of cans, that's C, that would be 1 more than 4 times B. And that would be one of my equations. C equals 4B plus 1. And then my other equation would be what I know about them together. And this would be exactly the same as the other one. It would be the amount of money I earned from the cans. Well, let's see, I got, 10 cents per can and 12 cents per bottle. So 12 cents times the number of bottles plus 10 cents times the number of cans equals the total amount I got, $2.18. And I now have two equations with two variables. And much of the rest of this chapter is about how to solve what's called a system of equations. That's when you have more than one equation with more than one variable. For instance, here I have two equations with two variables. And you might remember from last year we could solve this by the substitution method. We're not actually going to solve it, but I kind of want to start it for you. One way to solve this would be to substitute what C equals in place of the C. And that would give me 0.12b plus 0.10. Instead of 0.10 times C, it would be 0.10 times 4b plus 1 equals 218. Which, once you make the substitution, now you're back to the exact same equation with one variable that we did back here. All right, we just got the same equation. Oops. We just got the same equation that we had right here. All right, so listen. The goal here was to talk about how to write a let statement. Make sure that you write a let statement, including always put the units, inches, feet, gallons, number of zebras in your let statement. And then how to take your let statement and use it to write equations or statements for other unknown amounts. I think that's enough. I think you're ready to start the homework. Good luck.